Hello guys, welcome back to my channel, Method African Motives, working on mathematics for N5 level. So if you are new guys, you can consider being part of the family that is Method African Motives, so that you can have as much classes from this platform that we have, working on revisions and introduction of topics and so forth. So that's what we have guys. We are going to work on limits and continuity, that is actually revising past exam papers that we have. So guys, don't forget to be part of the family, Method African Motives, by just subscribing. So I'm just going to show you a glimpse that is of the notes that you can just have maybe from your N4. Yeah, from your N4. Remember your limits, the general concept of limits, that the limit, when you are limiting to infinity of a fraction where x is approaching to infinity, that's going to give you a 0 there. Working with 0, then it gives us infinity, that is a number. Just take a number like 2 over 0 there. It gives it approximates to infinity. So it can be any, here it can be any number. It can be 10 over infinity, and this is going to give us a 0 like that. So that is the concept. So, and we've got the theorems and concept that we need to understand when working with the limits. That is maybe you are multiplying, then by the constant you can actually separate the two by just multiplying by the constant. You are adding or subtracting limits, you can also separate them, add or subtract, but this is not valid when working with what, with logarithm. So some of these, they have where they can be applied, or some where they do not apply. This is actually from your N5 and so forth. So I just want you maybe to have all these, and it can help us as we are going to move, because I'm just going to explain actually the concept, because I have got question papers that I have got that I want us to at least work on and so forth. And mostly the most important part, that is the application of what, the helps. Remember, when you denote a 0, 0, you can actually use the long division, but this was actually from your N4 concept. So I'm not going to focus on this much. I'm going to focus on the application of what, of the L'Hopital's rule. This is the one that we are going to actually focus on in our syllabus, which is very, very important. So guys, not wasting your time, this is what we have, and let us quickly rush to the question papers. And we've got the concept that you're going to use. Remember, when applying the L'Hopital's rule, that is, you are going to be focusing to have fraction. Make sure that you have fractions, so you have to re-express your expression is e to the exponent of x, maybe it's sine x plus 1, whatever. You must have a fraction. All right, so this I'm going to explain, and also the part of continuity, that's one I'm going to explain from past exam papers. All right, so this is the first part that we have from one of the question papers that I just took. This question, we are asked to determine the following limits. These are the limits that we are given, guys, that we want to focus on. All right, so the first part there is the limit that you are given of e to the exponent of x over x into e to the exponent of x minus 2x, and that is actually 2 marks. So what do you do is that you substitute, okay, the value of x that you are given here in place of what, in place of x you're going to substitute x everywhere. You're going to substitute 0 there in place of what, in place of x. So you're going to see that, okay, this is 1.11. If we are to do this, guys, this is what is going to happen. If we substitute a 0 here, it's going to be e to the exponent of 0 over, that's going to be 0 here, and this is e to the exponent of 0. So you just make sure that you substitute everything as 0 there. So this is going to simplify further into 1 over, and as you can see, this will be a 0 and this will be a 0. So it's going to be 0 minus 0, which is a 0. And if you are to cross check from that concept that we talked about, we said k over 0 approximates or gives us what, gives us infinity there. So which means this is 1 over 0, which is going to be equivalent to infinity. So I think this question is actually good for the introduction and for the understanding that 1 over 0, a constant over 0, approximates or gives us what, infinity there. All right, Then on 1.12 we are given sec, this is 1.12 where we are given the limit of sec x minus tan x. All right, this is what we have, and we are given that x is supposed to approach to pi over 2. X is going to approach a pi over 2, which is actually 90 degrees, because remember 180 degrees is equal to pi, or you can just use your calculator in radians. It's going to be difficult for us to like simplify like this, but if we are to use fractions, then it's going to be easier for us. Remember, from your fractions you can simplify this, because you understand or you know that sec is actually 1 over what? 1 over cos x minus tan, which is sine x over cos x. So you're now back to your algebra there, working with fractions, addition and subtraction, where you know that when the denominators are the same, you simply subtract the numerators because these are the same. So it's 1 minus sine x. This is what you're going to obtain on top. So if we are to write this as a fraction, it means we have got limit of this fraction 1 minus sine x, which is very easier for us to clearly substitute the value of x when it is going to approximate or to approach to pi over 2. So if our x is pi over 2, this is going to be 1 minus sine pi over 2, okay, over cos pi over 2. And make sure that your calculator is not in radians. So simplifying this, pi over 2, sine pi over 2 gives us 1, so this is going to be 1 minus 1, which is a 0 here. Cos pi over 2 gives us a 0, so this one is going to give us 0 over 0. So that means we have to apply now our L'Hospital's rule, which says that when we can obtain 0 over 0 like that, what you are going to do is to apply L'Hospital's rule, which states that, sorry guys for this traffic thing that we are having. What is clearly happening, you're simplifying the derivative of both the numerator and what? The denominator. That is what you do. So you find the derivative of the numerator and the denominator. So this is what you're going to have. So let's just put equal to here. You shall have limit as x is going to approach to pi over 2. So like I said, you're going to find the derivative, okay, of both the numerator and what? The denominator. So you're talking of the numerator and the denominator at the same time. Denominator, like that. All right. So that means the derivative of 1, remember it's a constant, that's a 0 there. So you're going to have 0 minus, remember the derivative of sine changes into what? Into cos. And the derivative of cos is negative sine. So this is what you're going to have at the end. Okay, so we can actually apply our limits and see what is going to happen here. And applying our limits, that is pi over 2. Remember we said cos pi over 2 in this case gives us what? Gives us a 0. And we said sine pi over 2 gives us what? Gives us a 1. So this means that we are going to have 0 minus cos x, which is cos pi over 2, which you said is what? It's a 0 here, over minus sine x, which is sine pi over 2. We obtained 1 from the previous case, if you still remember. So this will be 0 over minus 1, of which, guys, any number, if it is being like 0 divided by any number like this, it gives us what? It gives us a 0, just like 0 over 2. So 0 over k gives us a 0, not infinite, but a 0. So this is going to give us a 0 at the end. So that's what we had, guys. So as you can see, to apply the L'Hospital's rule is simply to find the derivative of the given part that you have, then you substitute whatever that you be given and see. So sometimes it might give you 0 over 0, which means you apply again L'Hospital's rule. So that's what we had. And there was another part there. Okay, what was the part here, which is determine whether f of x is equivalent. This is x to the exponent of 3. So I actually saw like there was a 5, but this was x to the exponent of 3. So we are given a function of f of x which is equivalent to x to the exponent of 3 minus 27 over x minus 3. And the question is this function continuous? It's a question that you're being asked. Is this continuous? That is the question. At a condition where x is equivalent to what? To minus 3, is it continuous? So we know that if it is continuous, it means it is going to give us an exact value. When I'm referring to exact value, it can be a fraction, it can be a decimal, it can be a whole number, it can be any number, but it must be an exact value. When it is discontinuous, it means it is not exact. That is, it is undefined. That is to be discontinuous. So continuous, it's exact. So let's substitute when x is minus 3 and see if this is going to be exact. So f of minus 3 simply means in place of x substitute minus 3. So it's minus 3 to the exponent of 3 minus 27 over x, which is minus 3. So it's minus 3 minus 3. And if you have to simplify further, this will give you minus 27 over minus 6 from your calculator. This will give us 9, because it's going to be minus 54 over minus 6, which is a positive 9. And 9 is an exact value, which means this is what? This is continuous, guys. Continuous. So it is continuous. This continuous may be obtained actually maybe 1 over 0 like that. This one is discontinuous, or maybe square root of a negative number. This one is discontinuous. Okay, but this one is continuous. It's exact. It's an exact value. All right, so that's what we had from this part of the question paper. We are going to move on to another question paper that I had here, which is to determine the following limits. That's another question paper that I just got. When x is approximating to infinity, or when x is going to approach to infinity on this given particular function, where we have given x over ln x minus 1 over ln x. So we are being asked, okay, so it's these are separate fractions. It's going to be difficult for us to realize what's happening here. So the best, combine them to be a single fraction. So actually here we are just going to do it here, because remember I told you guys, when the denominators are the same like this, just combine your fractions. Okay, just combine the numerators, and this is going to give us the limit of x as it is going to approach to infinity. So just combine, that's x minus 1. All right, so that's x minus 1 like this over ln x. So that's what you're going to have here. You can put your brackets if you want. You can actually do that. So the question is, if we are to substitute here infinity, here the infinite part here, substitute infinity, is going to be infinity minus 1, guys. It's like you're subtracting nothing, so it will remain as infinite. Ln infinite, that one is actually infinite. So this one is going to give us infinity over infinity here. So which means if it is a condition like this, apply L'Hospital's rule, which states that I have to find the derivative of both the numerator and the denominator. All right, so that is the case, guys. Let us find our derivatives. That's gonna be limit as x is going to approach to infinite of the derivative of x. Remember, that's x, that's a, because we are given ax is a. So here it's 1x, which is 1 minus the derivative of 1, that's a 0 there. So it's just 1 minus 0, guys, which is just 1. Okay, what about the derivative of ln? Remember, if you are finding the derivative of ln, it's the first derivative of x over f of x. So it's just first derivative over f of x. So the first derivative, that is 1 over x. So it's going to give us 1 over x like this. All right, so let's just move on, guys, and see what you're going to have as x is going to approach to infinity. That means it's 1 minus 0 here, which is 1 over x like this, which is the inverse, guys. You know that from your mathematics, guys. From your mathematics, you know that 1 over 2 like this gives you 2. It's the inverse of 1 over 2. So 1 over x is going to give us x. All right, or it's just 1 multiplied by x over 1. Remember, when you multiply, you invert the fraction, so it's just going to give us x in this case. So it means all this part that we have from this part here that we had is going to give us x. So this will be limit of x as x is approaching to infinity. So this is going to be just x. In place of x, it's just going to be infinity, guys, as you can see. So that's what we have, because we are saying x is approaching to infinity and it's just x. So it will just remain like that as an infinite. Just like if x is going to approximate to 2, you just put 2. If 3, you just put 3. So it's infinity, so you just put infinity. That is the case that is actually happening there. So as you can see, guys, these are some of the typical questions that they can actually ask you. And let's see the number 2, the 1.12 now. We are given a certain limit there on 1.12, which is the limit as x is going to approach to 0 of x cubed minus 2x minus 5. So on your mathematics N4, that's where you used to do all those long division and so forth. But this time, guys, we are focusing with L'Hospital's rule. So as x is going to approximate to 0 here, let's see if it is going to be exact. Sometimes it's just going to give us exact values. Sometimes it is not going to give us something like that. Then what are you going to do? You have to apply the L'Hospital rule. So in this case, let's test when x are going to approximate to 0. That's 0 here, that's 0 here, that's 0 here, that's 0 here. So as we can see, this is going to be limit as x approximates to 0 of actually we have applied this is 0, so there's no need for us to put the limit, because this is exact, guys. This is just going to give us -5 here over 0, because 0 minus 0 is 0, guys. So -5 over 0, remember any number over 0 approximates now to infinity, so this is going to give us infinity at the end. So that is the case. So as you can see, guys, this one was just direct 2 marks for that. And yeah, it's something that was worthy 2 marks. And determine whether f of x, which is given as 4x minus a half, is continuous at x is equal to -1. And I explained about this part that when it is continuous, it must be exact. So this one, is it going to give us an exact value? That is the question now. All right, so let's see. If x is equivalent to -1, that means in place of x here, I'm going to substitute -1. So f of -1 is going to be the square root of 4 into -1 times a half. And this is going to give us from our calculator, that's -9 over 4, 9 over 2, because this is -4.5. And can we simplify this from our calculator? Actually, this is undefined. All right, or this is not exact. It's not exact, it's undefined, so therefore it is not continuous. So if it is not continuous, it means what? It is discontinuous. That is what it means. So it is what? Discontinuous. So that is the case, guys. As you can see, that was actually 7 marks, just mostly 7 marks, 8 marks, and 9 marks, but mostly 7 marks on this particular type of equation. So like I am explaining that the limits, the continuous part, the continuity part, this is something that is direct. Let's see if I got another question so that we can just work on it together. We have got something that is this one is another typical type of equation that you're supposed to understand, actually, because they want to test you. Do you understand what you're doing there? Because actually here you're given that determine ln y. If ln y is equal to this, there is nothing that they are asking you to do there, guys. Nothing, actually. What you simply do, because you know your limits, isn't it? Now you know your limits from this part that we have just explained. Maybe you were having some confusion there on limits, but now you actually know your limits. So that means it is going to be easier for us, because when you're given something like this, you want to determine ln y in this case, and ln y is equivalent to what? To this limit that we are given here. So it's simply finding the limit. Whatever that I get, it is equal to what? To ln y. That is the case. So it's simply finding the limit of this. Whatever that I get is equal to ln y. So not to forget or not to confuse myself, I'm just going to write ln y throughout so that I know that I'm not going to confuse myself. So ln y is going to be equal to, so this is what I'm going to test when x is equal to what? When x is equal to 9, are we going to obtain exact value or not? This is 9 here, so it's going to be square root of 9, which is 3 minus 3 over 9 minus 9. So this one is 0 over 0. So as you can see, we are obtaining 0 over 0 there. So we have to apply our L'Hospital's rule. So that is the case, finding the derivative. But this is square root of x. So to find the derivative of this, is easier for me to write it as x to the exponent of half minus 3. Alright, that means like this I can find the derivative, because the derivative of this, I'm going to drop the exponent and multiply with 1. So it's 1 times a half, which is half x to the exponent. If I subtract 1, this is going to be minus half minus a 0 here, because this 3 which is a 0. So which means I'm going to remain with this as my derivative from the numerator, the whole of the numerator. Alright, so this is going to be equal to limit x is approaching to 9. So we have applied the L'Hospital rule here, which is a half x to the exponent of a negative half minus 0, which is just like that. Okay, over what am I going to obtain in the denominator here? The derivative of x is what? Is 1 minus 0, and 1 minus 0 is what? It's just 1. So which means this is what I'm going to have. So that means my ln y is going to be equal to, now I can substitute the value of x, because as you can see, this one is now direct, guys. In place of x, substitute 9. So it's like this, half of 9 to the exponent of minus half. This is over 1, so it does not have any effect, or it doesn't cost us like that. So this is going to give us 1 over 6. So that's what you're going to have. So this is the term or the number that is representing ln y. So that is your ln y. Ln y is equal to 1 over 6. Alright, so that was the question, guys. So don't panic when you see these ln and so forth. Don't panic. It's just a direct thing that you're simply doing there. Now, so this question with a now can be given as hence. Okay, hence it's a continuation from what you have just obtained. Now determine the value of y. So it's a continuation from where? From this statement that we had on 1.11, this one. It's a continuation. We obtained ln y, which is equal to 1 over 6. So to find the value of y now on 1.12, it's a continuation that you're going to do, because you obtained that ln y is equal to 1 over 6. So if ln y is equal to 1 over 6, what about the value of y now? Remember, ln, it's a log that is in base of what? That is in base of e. It's in base of e like this. Log of y in base of e, that is what ln y represents, which is equal to what? 1 over 6. So to find y is simply what? E to the exponent of what? 6. From your N4 mathematics, guys, you know that this is your a, which is equal to b to the exponent of c. So it is going to be e to the exponent of 1 over 6. All right, and yeah, you can leave your answer like that, or you can simplify from your calculator. This is going to give us 0 comma, not 0 but 1 comma, this is going to give us 1 comma 1 8 1 3 6 and so forth, which is going to be 1 comma 1 8 1. Yeah, there's something like that. So this is the value of what? Of y. All right, on 1.2 there we are now given to determine the limit. Now it's the limit that we are given. So as you can see, this one we did not have anything that has to do with continuity. It's just limit there. All right, so let's just take our question and see what you're going to have. Actually, let me just start by substituting so that we do not waste much time, and see if it is going to give us exact. This is 1 here, so this is 1 minus 1, which is actually 0 over this is 1, and this is minus 1 minus 1 ln 1, and we know that ln 1 is equal to what? To 0. So it's 1 minus 1, so that's 0 minus 0, so it's going to give us s0 over s0 here. So we are going to find the derivative. So which means we have to find the derivative of this 1 minus what? 1 minus x squared. But how am I going to find this derivative, guys, of 1 minus x squared? How? You can actually determine this direct. Remember, from your brackets, you can find the derivative of a bracket, which is 2 into 1 minus x. You subtract 1, then you find the derivative of minus x, which is minus 1, which is going to give us minus 2 into 1 minus x, like this. which is fine, which is minus 2 plus what? Plus 2x, like that. So this is your derivative. Maybe it's not exact. Maybe it's not exact. What am I going to do? I have to expand the brackets. 1 minus x into 1 minus x. Okay, that's 1 and 1, which is 1. 1 and minus x minus x and 1 minus x, which is plus x squared. Okay, that's 1 minus 2x plus x squared. This one is x squared. This one is minus 1, so it's minus 2x. Now you can find the derivative. This is 1, which is a 0. The derivative of minus 2x, which is minus 2. The derivative of x squared, which is 2x. So as you can see, we are obtaining the same answer as this one. Okay, so this one is going to give us limit minus 2 plus 2x. This is the top part, which is the numerator. Okay, then let's move on to our denominator here. It's x squared, so it's going to be 2x. Okay, this is as x is approaching to 1, so it's going to give us 2x here. The derivative of minus x, this is minus 1, so it is going to give us minus 1. Then we have got minus the derivative that is going to happen of x ln x. And how do you find the derivative of x ln x? Okay, x ln x, this is going to be from your product rule. This is your u, this is your v. So remember, from your product rule, you can write in either way. You can write this as v, the derivative of u, plus u, the derivative of v. So our v is ln x by the derivative of u, which is 1, plus u, which is x, times the derivative of vx, which is v is 1 over, which is 1 over x. Remember, ln is 1 over x. All right, so this is going to give us ln x, and x can cancel, which is 1. So you're going to obtain ln x plus 1. Is that so, guys? Okay, but remember, there is a minus that we had from this part, so you must be very, very careful of the minus here that we have. So it's minus into, we obtained ln x plus what? Plus 1. So if you multiply by minus, it's going to be minus ln x minus 1. So you're going to write minus ln x minus 1. This is what we want here. So we want minus ln x minus 1. And this is minus 1, which can give us minus 2 if you have to cross-check properly, guys. So you can actually obtain minus 2 there. All right, anyways, let's see if we... Okay, let's just simplify, maybe, because I might confuse someone. So let me just simplify further. Minus 2 plus 2x over 2x, we said minus 1, it's minus 2 minus ln x, like this. Okay, as x is approximating to 1. So let's test if x is equal to 1. This is going to give us a 1 here, a 1 here, a 1. So this is minus 2 plus 2, which is a 0. 2 minus 2, which is a 0. And we said ln 1 is a 0, so it's going to give us again 0 over 0. So we have to apply again L'Hospital's rule. Find the derivative again. So let's find the derivative again. So it's going to be limit the derivative of minus 2, that's a 0, plus the derivative of 2x, remember, is 2. So 0 plus 2, that is 2, over the derivative of 2x, that is x. All right, that is 2, sorry, guys. This is 2x, so it's going to be 2. And minus 2 is a constant, which is going to give us a 0 there. Minus the derivative of ln x, which you said is 1 over x from our previous question that we did, and x is approximating to 1. So let's test and see what you're going to have here. 1 over 1, this is 1, so 1 over 1 is 1. 2 minus 1 is 1, so which means this one is going to be exact. So there's nothing that you're going to do but to simplify. So it's going to be 2. There's a limit, there's a number 2 here, so you don't apply any limit. Okay, just leave it like that. And here there's a number, don't apply anything. That is where you're going to apply. So it's 1 over 1, which you said is what? Is 1. So it's going to give us 2 over 1, which is going to be 2. So this is going to be your answer at the end. So as you can see, guys, it was actually something else, and that is how they actually ask these questions. It's a matter of application of the derivative. So you must be very, very good also in your derivatives in order for you to be able to to apply the limits, you must be very good in your derivative, so that it can be easier for you, knowing your product rule, your quotient rule, the derivatives of ln, x, and whatever that you be given, trigonometric expressions, all those you must be very good at. So that's what we have, guys, from this platform. We shall meet again in another class or in another classes working on the particular section and other sections for mathematics and 5. So not to miss these classes, make sure that you're part of the family Maths on African Motives by subscribing, and also don't forget to share our videos to your friends and colleagues so that they also can benefit from this platform that we have as a family Maths on African Motives. Till we meet again.